Hello, welcome to week 5 summary video. In this week, we will continue learning more about forecasting methods. Let's remember what we were up to last week. In week 4, we got the introduction to forecasting methods. We studied the good characteristics of a forecasting method, and we categorized forecasting methods into two, qualitative versus quantitative forecasting methods. And last week, we also studied moving average and weighted moving average forecasting method. That is one of the quantitative forecasting methods. And then we used it to predict for future values by looking at the historical data. So in this week, we will continue learning more about forecasting methods. More specifically, in this video, I'm going to show you the basics of exponential smoothing method. All right, let's get started. As I told you before, these videos are summary videos, and they include the topics that I handpicked from your textbook material. Please review your textbook material first, and then try to watch these videos to learn more about the details of some of the most important concepts that I handpicked from your chapter material. Okay, so let's get jumped in right into the topic of this video, and it is exponential smoothing. It is another forecasting method, and then you're going to understand after this video you're going to understand the difference between exponential smoothing method and hopefully moving average method over an exercise that's coming up on the next slide. But let's just focus our attention to this formula right here. After doing some rewriting for the future one time ahead forecast that we are trying to calculate is going to depend on the forecast that we make for the current time period plus an alpha, a constant value between 0 and 1, times the actual value that we observed for the time period t minus the forecast again that we made for the current time period. So by using this iterative method, we get to update our forecast and we get to make a forecast for the future time indexes that we are analyzing. Okay, so this formula right here is just word representation of what's going on here one more time. An important factor that we should understand in exponential smoothing is selection of this alpha value. How do we know that we select the best alpha? Well, it is still a discussion of research. People are still working on this, but there are some optimization algorithms and the methods that you can call to optimize your alpha value. For the sake of simplicity, in this course, we're going to assume that the alpha value is going to given to you already. All right, so let's jump into this exercise where we get to sharpen our skills on both moving average method and exponential smoothing method one more time. So you recall this exercise from last week's videos. We are going to work on it this time by using exponential smoothing method, and we get to compare our results with moving average method. Okay, so in this exercise, we are given the weekly sales, okay, of a product. All right, let's try to put this in a table format. The time period is changing from 1 to 2, 3, 4, 5, 6, 7, and 8. Or maybe I should get them scaled a little bit here, this way. Okay. And then I do have my AT values, the actual observations, and those are 14, 19, this is 4, 30, 22, 34, 12, 19, and 23. And my future value, my forecast value, by using exponential smoothing with alpha value equals to 0.15, right? And I am going to calculate my forecast values by using these parameters. Okay, let's read the question a little bit in detail. It basically says that use exponential smoothing method with alpha equals to 0.15 and determine one step ahead forecast for weeks 4 through 8. Why 4 through 8? Because we also came up with a forecast for the same problem in the previous videos by using moving average method with n is equal to 3. Remember, we looked at 3 most current observations. So in that problem, we didn't have any forecast for the first 3 weeks. That's why this problem is telling us that we should also make a forecast for weeks 4 through 8 only. And then it gives us a hint, and the hint says that to get the method started, use the actual value of week 3 for the forecast for week 4. Why do we need this? We need a starting point, a starting forecast to get the exponential smoothing method to start working on the future forecast is because this is an iterative formula. Remember, ft plus 1 is dependent on my previous forecast values that I made earlier. And if I don't have any previous forecast value here, then I cannot really calculate the next one, right? So we will see, this in action to see, like, how important it is to have an important triggering, important starting point. And this time it is going to be starting at week 4. So basically says that don't make any forecast here, don't make any forecast for time period equals to 2 and week 3 as well. So our week 4 forecast is just going to be from this hint. It's telling us that your week 4 forecast should be equals to A3. My actual observation in week 3 is simply 30. All right, I'll get this as started, and I will try to rewrite my exponential smoothing forecasting function. Again, ft plus 1 equals to ft plus alpha times at minus ft. Okay, so according to this formula, if I'm looking for f5, then I need f4 plus my alpha value times my a4 minus f4. See, that's why, since I'm using these f4 values here, that's why I need a value for f4, and it is going to be coming from the question as a hint. All right, let's plug in the values into this formula. So to calculate f5, I need f4. f4 equals to 30 plus my alpha value equals to 0.15 given in the question. And my A4 actual observation for week 4 is actually 22 minus, and my F4 is again 30. If you do the math, you will get 28.15. Okay. So this will be our forecast that we make for week 5. All right. What about week 6? A quick question, right? So if I have a forecast for week 5, right, can I use this as a one step ahead forecast for all other weeks? Yes, I can. But remember, I already have observations for these weeks. So why am I using this as a forecast for a time period where I actually have the actual value, right? So that's why we are going to be updating these forecasts all the way down after we observe week 8, and then after that point we will be able to make a forecast for the future that's unknown starting week 9, 10, 11, and 13. Okay, so let's keep updating our forecasts. So for week 6, I do need f5 plus my alpha, again a5 minus f5. So f5 is right here. I just calculated it. My alpha is 0.15 and my A5 is 34 minus, again, 28.15. That should give me 26.98. F7. This time I'm not going to copy the formula, I will just plug in the numbers. F7 would be 26.98 plus 0.15 12 minus 26.98, and that should be 27.23. And then F8 would be 27.23 plus 0.15. 19 minus 27.23. And the forecast that I'm making for week 8 at the end of week 7, it would be 26.55. And now week 9, I don't have any actual value here, but I can still calculate my forecast for week 9 at the end of week 8, and that is going to be close to my forecast that I made for week 8 plus alpha value, my actual observation for week 8 minus, again, the forecast that I made for week 8. So if you plug in the numbers, times 23, all right, this number equals to 25.81. All right, so my forecast for week 9 is equal to 25.81. Could I got this earlier? Not without doing all these calculations. Unfortunately, no. In moving average case, for example, if you would like to calculate the forecast that you are for week 9, all you had to do is to come over here, take the averages of these three numbers. If your moving average parameter value is equal to 3, and then get the average of those, and then that will be your forecast for week 9. But in exponential smoothing, you have to do this iterative process. Otherwise, you will not be able to get the forecast, accurate forecast for week 9. That's actually one of the drawback of using exponential smoothing method. Okay, so these are the values that we calculate as a forecast for exponential smoothing method. If I just summarize them here, so the formula here, one-line formula is everything. And again, remember, you don't have to memorize this formula at all. All you need to do is to know how to implement it. And the next forecast, one step ahead forecast, is equal to the forecast that you made for the current time period plus alpha, a smoothing factor, a value between 0 and 1 times the differences between the actual observation and the forecast, again, that you have for the current time period. Is going to give you your exponential smoothing forecast for one step ahead. In the next video, you're going to see how we can use certain methodology to differentiate between a good forecast and a bad forecast.